Welcome to the Clear to Send podcast, a podcast about wireless engineering, where we educate you on Wi-Fi technology, talk about design tips, troubleshooting, interviews, and the tools. Here are your hosts, Roel and Francois.
Hi guys, welcome to a brand new episode of the Clear to Send podcast. This is Francois, your host. I'm here with Roel this morning. Hey Roel, how are you?
Hello, good morning.
Good morning, and today's the day we talk about the future of Wi-Fi. A whole bunch of new acronyms, new letters, Wi-Fi 7, all of this good stuff.
Yeah, we're going to skip Wi-Fi 6 altogether and just go straight to 7.
Yeah, exactly, because no one wants Wi-Fi 6, right? It doesn't work.
Apparently it doesn't. And in this document that we read, apparently it really doesn't work, or it's not as good.
Yeah, so the premise of this episode comes from a document published by the IEEE on the current state of the next iteration of Wi-Fi, which is called 802.11be. And it's a good read, and it gives a lot of good information, technical information on what's not currently working in Wi-Fi and the potential solutions that the people are studying, or the IEEE is studying. And so we thought it would be a good idea to just share some of what this document is talking about with you guys, and just discuss together what this means for us. Because obviously it's not for tomorrow, and it's a lot of theory.
It's very much theory, because there's nothing in place to even verify any of this is working. But the IEEE has working groups to always move to improve Wi-Fi, right? So once AX was done, they started this new working group to build the next version, the next better version of Wi-Fi. But this document specifically, I think, talks about what has been discussed in this working group, and anything we mention here may or may not be implemented in the final version, right? Because there's really no draft to this yet.
And also when you read the document, and I think in the introduction they talk about the fact that they are talking about it right now. They're publishing this document also to spike interest in the academia world, so people can actually do some research on on some of the solutions that they're proposing, right? So they're also trying to spike interest for some maybe students working on their PhDs. Maybe they can work on some of those solutions. That's what I got from the document as well.
Yeah, they definitely try to tap into the academic world in trying to help get more information into this working group. But a lot of this it reminds me of how much I don't know about Wi-Fi, right? It's just the technology itself is so complex, and I'm just an implementer in all of this.
I was thinking, reading the document, I'm thinking now that it makes you, it wants, how should I say that? It makes you mad, or even madder at people that takes Wi-Fi for granted. It feels like you want to be even madder at them. Like, do you even know how it works?
Do you know how hard
when people tell you,
took?
oh, it works, right? Just put an AP here, it works.
Right. Like people who maybe put in complaints about how slow Wi-Fi is, and you're like, do you know how hard it was to get you that 100 megabits per second?
Yeah.
Because we're talking a lot more higher speeds in 802.11be or Wi-Fi 7.
Yeah. So and they talk a little bit about why, the goals they're trying to achieve with 11be, and they're saying they were going back to 11ax. They were talking about the fact that when they worked on 11ax, the goal was to improve the efficiency. So they kind of left the throughput, the increasing throughput alone for a little while, and they focused on the high efficiency. And then now for 11be, they're saying that they're going back to increasing the nominal throughput as the main objective, and that's what they're talking about. And they're talking about trying to achieve up to 40 gig over the Wi-Fi connection.
Yeah, that's data rates of 40 gigabits per second, which is crazy because I barely see 1 gigabit per second data rate.
Yeah. And the
So
question is, do you need 40 gig, right?
yeah, well, the goal of Wi-Fi 7, I think is what it's going to end up being called, is for real-time applications, low latency applications, gaming, and with this comparing to 11ax, it's true they left out higher throughput from 11ax and really focused on trying to build that efficiency in the wireless Fi and Mac, right? So with that, this this document really goes into 11ax to talk about its inefficiencies and what they are missing in 11ax and what 11be could provide to increase that bandwidth or that throughput.
Yeah, and also I didn't mention it, but if you're interested in reading the document, it's actually publicly available. So we'll put a link in the show notes, cleartostand.net/236. So if you want to take a read, you guys can go ahead.
Yeah, so 11be will be, there's so many names to it, right? 11be,
yeah,
it's probably most likely going to be called Wi-Fi 7, and it's also going to be called extremely high throughput.
Yeah, it's interesting, huh? We went back to the high throughput stuff.
Yeah, and I think it makes sense, right? In order to get that higher throughput, you do have to create better, more efficient in the way that technology works. So I don't think 11be would be there without 11ax. So they build upon those efficiencies to gain the throughput.
Yes, I agree. And they talk a lot about that in the document, a lot about the AX features and how they could enhance them.
Yeah,
improve them.
And in short, a lot of these probably sound unattainable because we're talking 4,096 QAM, 320 megahertz channel widths, MU-MIMO working.
with 16 spatial streams.
16 spatial streams, yeah, you name it. So I don't know what technology is going to look like when this is out. Like, are bigger phones? Are batteries going to get better when this is released? Because batteries are not very good nowadays.
Think about the AP supporting 16 spatial streams.
How big are these APs going to be? And it's funny reading this document because they do go back to AX and they're like, yeah, it gives us almost 10 gigabits per second. And I'm sitting here going, wait, I don't see that yet. Where is that? Like, where's the 10 gigabits per second? And then they do go into thing as if we're using 8K video and virtual reality, augmented reality as a normal thing, which I haven't used either of those yet.
Yeah, that phrase made me laugh, so I highlighted it in my document. Yeah.
Oh, like
they're like, oh yeah, part? We want to increase the nominal throughput so we can increase the or improve the user experience, and then into brackets they say, when you watch 8K video with uncompressed rate of 20 gig.
I'm like, oh, Francois, how's your 8K TV over there? I'm still on HD, by the way.
I don't even have a 4K at home. 4K TV.
I don't. So. Yeah, I don't either. Well, actually, I think I do. I just don't use 4K because I have nothing else that's capable of 4K. But this going through this document is not an easy read, right? So it requires multiple reads. It goes through the evolution of Wi-Fi, going back to the very beginning, and how we improve through each generation of Wi-Fi. And it's really nice to go through that to understand, all right, where did we come from? Especially if, you started Wi-Fi in a much later generation, right? Like I wasn't working too much with 802.11a and B. Like I really started working with Wi-Fi around 11n and knowing how the technology works and where the shortcomings are is important to know, like why we're here at 11be now talking about it.
Yeah, and then they're planning on releasing the first draft for 11BE in I think May 2021.
Yeah.
And then they're saying that they're not going to be able to include everything, all the key features of 11BE. So for that first release, they're going to focus on supporting 320 megahertz wide channels, 4K QAM, because that's how you
Yeah,
call it now,
4K. Yeah, you're not
4K
going to
QAM.
say 4096 QAM.
Yeah, 4K QAM, and then some obvious OFDMA improvements, which are important. We'll talk about that, and then maybe supporting multi-link. We should talk about
Yeah,
multi-link
the
as well.
multi-link part is interesting. So when we go back to this, the 4K QAM got me confused initially because I thought they were referring to 4K TV.
Yeah, no, it's 4096, I guess.
Yeah, which again, you look at real world implementations, and I mean, what's the best highest QAM you've seen, Francois? 1024.
1020, yeah, I see 1024 when I'm like close to the
Yeah,
AP.
in the lab when you're
Yeah.
right next to it.
Yeah. Well, so the issue I have with QAM, like with the highest or the more complex QAM technique, is that it requires a higher SNR, and also because the device rate shift, when they're not able to achieve it, you have retries, and then that generates more overhead on the Wi-Fi, and then they down shift it to 256, and then after a while they go back to 1024, and then that all of these rate shifting generates a lot of overhead and
Right.
retries. So the efficiency that you gain by using more like a more complex QAM technique, sometimes you lose it because of all of these retries
Right.
in the real world.
Yeah, and retries I see still a lot happening today. Like I was troubleshooting some Wi-Fi, like a residential.
Okay, wait, are you seeing Wi-Fi doesn't work sometimes?
Wi-Fi doesn't work sometimes. Well, it works, but just not to what people think, right? If you're saying,
Yeah.
if you've got, let's say you've got gigabit to the home, but then your Wi-Fi is not gigabit, then people start going, what's going on? Like I have 802.11, I have Wi-Fi 5. I should have gigabit speeds, right? But then there's all sorts of retries, low RSSI, low SNR. And that's what this document tries to go into is, okay, how do we get to the higher 4K QAM without the limitations of the SNR? So they have to increase SNR in order to get there. So they didn't leave that out, right? They know they're not going to try to avoid that. They have to address it somehow and increase SNR at the device level.
Yes, and they say that later on in the document, I think they say that you need an SNR of 40 dB.
Yes.
In order to be able to achieve 4K QAM. So 40 dB SNR is pretty high.
I would say you'd have to be today you'd have to be pretty close to the AP with a clean environment, right? And I don't know how many of us document or calculate what the average SNR is in an environment. I think that would be an interesting number to start documenting now as we go into Wi-Fi 6 and then into 11BE, is knowing, all right, what's our SNR like? Are we averaging at 20 or are we at 30? Are we getting to closer to 40? And if not, what are the factors getting there? And I think that'll help us understand how 11BE and even 11AX will be implemented and what your expectations will be.
Yeah. Well, I was looking at my SNR right now and I have 48, but I'm right next to the AP, right?
Yeah, you're right next to the AP. So I'm not next to my AP. I know my AP is transmitting at a fairly high transmit power, and I am at SNR 16. But I'm hardwired.
Wow.
I'm hardwired in right now. So
Okay.
Otherwise our recording wouldn't be good.
Yeah. Well, I'm looking at the list of devices in my house. I have SNRs ranging from 30 to 46. So, I mean, I'm guessing you will be able to achieve it in some scenarios, but I don't think that's something you'll be able to rely on to for for everything you do.
Yeah, unless 11BE would somehow increase that SNR through, who knows, maybe beamforming will be better. I don't know.
Yeah, yeah, yeah. Oh yeah, they do talk about that as well. The only thing they say about beamforming is that um, um, if you use beamforming, so it means you use more antennas for that,
Yes.
and therefore you cannot use multi-user MIMO. So it's kind of like one or the other. Oh, yeah.
Yeah,
So
there's a lot of scenarios where one piece of the technology might sound good, but then you can counter it and say, well, here's where it would fail.
yeah, yeah, yeah.
Right. So, in order to achieve this, we would need much better radios and more control over the RF communications and access to the medium. And
Yeah.
this document does talk about access to the medium. And I think particularly interesting was where it talks about QoS, for example, and how right now we're only using EDCA, right? Enhanced distributed channel access, but it doesn't guarantee like QoS. And that's something that they really want to focus on for low latency applications and in order to get the higher throughput. And so go ahead.
there's one acronym that is used a lot in the document is RTA, real-time application.
Yeah.
And they're saying, for real-time applications to work properly, you need a low latency network, high throughput, low latency. That's what they talk about all the time.
Yeah.
And they're saying that low latency in Wi-Fi is very challenging because of just the nature of the unlicensed band. And also they talk about what you talked about, the unguaranteed QoS with what we use today with EDCA. And then you were going to talk about hybrid.
Yeah, they want
right?
to they want to look at hybrid, the hybrid
coordination function.
I can't remember the acronym. There's too many acronyms, honestly.
The hybrid coordination function. Yeah.
Yeah, and they want to be able to have some applications gain access to the medium more in a more determined fashion, right? If the application was a more critical one, the communication was a more critical one over, say, like just background data, they want that communication to be able to take higher priority and just gain access to the medium. And so when you think about it that way, like we don't have, like Wi-Fi just doesn't work that way, right? It's more about if you can get access and get that transmit opportunity, then you can send your transmission. And so that's what they're trying to improve here is the different ways to gain access to the medium that's in a more efficient manner, but still implements QoS.
Yeah, and one of the solutions they are looking at is something called TSN, time sensitive networking. And I think from what I understood is it's not something that's new, but that's something they're trying to apply to Wi-Fi communications. And it's just a way to be able to achieve that. And they were talking about the challenges of making that happen over a Wi-Fi connection.
Yeah, and even with Wi-Fi today, with enterprise Wi-Fi, they are trying to include something that has multi-AP cooperation, and that's more along the lines of transmissions being coordinated between surrounding APs on, I guess, on also the same channels. And how see, like we can keep jumping between different topics because once I mention channels, there is another section that talks about how like multi-link devices and using the channels on different links to try to get more efficiency and higher throughput. Like there's a lot that goes into this that I think this adds so much complexity on the device manufacturer side. And there's going to be so much relying on the actual drivers of these devices, because
and that's when a lot of testing needs to be done. Yeah, going back to the the QoS thing. Um, so the way it works today, like if you use EDCA with the different quality of classes of service, we have 4 classes of service,
Yeah.
and the way it works is if in order to prioritize the higher quality class of service, we pretty much try to give them channel access faster by giving them a smaller contention window and giving them shorter interframe space. But the device still has to choose a random backoff number, and that's what introduces the the fact that QoS is not guaranteed,
Yeah.
right? And so here they're talking about the TSN stuff, and they're saying that with TSN you could have there's a feature that's you could actually, when a device that actually needs to transmit right away could be stopping an ongoing transmission, right? And then tell them that, oh, I have something urgent that I need to transmit. It's kind of like when you have the ambulance on the road, right? The ambulance, they have a siren, and when the siren goes on, everyone stops. Yeah. And then the ambulance guy goes. So it's kind of like this. And then they're talking about how that could work in a Wi-Fi environment when it's usually listen before talk, and then when someone's talking, no one's like everyone is quiet.
You gotta they use the term like puncture. They like kind of puncture. You're basically sending a transmission, even though transmissions could be already in the air, and then everyone else kind of like moves to the side while this emergency transmission goes through.
And and then that's when they start to talk about maybe leveraging some of the AX capabilities. So they say maybe we can use a trigger frame and then allocate different RUs for very sensitive traffic. So you have like some sort of dedicated resource units for highly sensitive traffic.
Predetermined size of the resource unit. And it's funny because they already say OFDMA is insufficiently flexible.
Which
it really is, right? It's the first implementation of OFDMA in Wi-Fi just to make it more efficient. But BE, they're like, it's not that efficient. We need to make it more efficient.
The 11AX is especially the OFDMA subject, I think is interesting in this document, right? In the introduction, they said that in 11AX, OFDMA is, like you said, insufficiently flexible. So, and the reason why they're saying this is because it allows the AP to allocate only one resource unit of predetermined size to a client station. So, and this is true. If you look at the draft for AX, you can see that they clearly define which RU size you can use, and this is like predefined, that they kind of cookie cut the channel into different RU size. And then they said the second, it does not support direct link transmission. So direct link means that 2 client stations can talk directly to one another without going through the AP, right? Which is not supported. And then they say that both drawbacks reduces spectrum efficiency. And besides the lack of flexibility of the legacy OFDMA, degrades performance in dense deployment and increase the latency, which is crucial for RTA or real-time application.
Yeah, when I read that part, I thought we were gonna get increase in performance and dense deployments and lower latency. With OFDMA.
Yeah, exactly. It's like what?
So what? So I was curious, like, what was that? Like, how much of that did we lose by adding OFDMA? Like, are we only getting a very small portion of efficiency increase by adding in this version of OFDMA? And that's still yet to be seen, right? Because it's just Wi-Fi 6 isn't fully mainstream yet. There's not many people with Wi-Fi 6 APs at home, and the only Wi-Fi 6 devices are our mobile devices.
Yeah.
So again, it's still all theory. You still have to somehow measure this. And I don't even know how that's going to be done.
And then in OFDMA as well, they're talking about a couple of enhancements. The first one is called Preamble Puncturing. Mm-hmm. And the idea behind preamble puncturing is it's more if you use wider channels. So let's say you use the 80 megahertz wide channels and you have the primary channel, and then you have your 40, I guess, primary megahertz channel, and then you have the second 40, I guess. So with the way it works right now is if one of the 20 megahertz channels is used over your 80 megahertz wide channels, you won't be able to use it, right? Because the medium is busy.
Yeah.
Yeah. So what they're trying to do is use a preamble puncturing, so you can detect if one of the 20 megahertz is busy, and then use the rest of the spectrum for your transmission, right? Yeah. Instead of just not transmitting, or just using the primary channel. Sometimes that could happen. Like if, let's say, the secondary channel is busy, then you can just use the primary to transmit, which is inefficient because you're supposed to be able to use 80 megahertz, but now you fall back to 20 because some of those channels are busy.
You're not able to use some of those channels, and it would then lead again to inefficiencies.
Yeah, so that with this preamble puncturing, they're trying to be a little bit mindful of that, and then detect which channels is free, and then use that for the transmission. And they're saying it's even more important as we go to 320 megahertz wide channels, right?
Can't wait to see that. Although with 6 gigahertz, maybe.
Yeah. Just to let you guys know, most of the time we use 20 megahertz wide channels in enterprise environments.
What?
Yeah, so
you're not using default 80, Francois?
No. And certainly not using the auto channel width feature.
Oh, the dynamic bandwidth.
Yeah, I've seen that this week for one of my customers. So
yeah, isn't that awesome?
Yeah, that's awesome. You see, I saw everything on one site, like 20, 40, 80. I was like, what?
Yeah, I see that too. Specific vendors with auto RF and it just allocating all sorts of different bandwidths. And then you're going to get OBSS. And they kind of talk about OBSS in this document, about how with OBSS, you could still, one, it'll still exist. And two, you'll get, again, less efficiencies because of that. Even though we increase our generation of Wi-Fi, we're still limited by the OBSS.
Yeah. Well, which is, I think, the nature of, I guess the way it works in Wi-Fi.
Right. And this is why I think we have to lower our expectations of Wi-Fi. Like Wi-Fi right now really is great at making it work, just not with, you may or may not get high throughput, right? But you still get Wi-Fi. You still are able to send communications out, just you're not doing it at gigabit speeds at the moment, right? Sometimes you'll get higher speeds, like maybe close to a gig, 800, 500, but most of the time in enterprise deployments, if you're using 20 megahertz wide channels because of channel availability, then maybe it's about 100 to 200 megabits per second.
Yeah, and if you look, like, realistically speaking, when you look at throughputs in a network today, you can get, like over the Wi-Fi, if you have a well-designed Wi-Fi network, you can get, well over 150 megabits per second of, throughput for every client, which is, more than enough, I think, for what we do today.
Yeah.
Even 50 would be enough for what we do today. Yeah,
but 8K is coming around the corner, Francois.
Oh yeah, I forgot the 20 gig uncompressed video feed.
And I would say the real-time applications is more critical than the high throughput. And so, yes, with this article, I would say looking at lower latency is important.
Yeah, I would think that's more important than higher throughput for the real world, I guess.
Yep. But then we would have to talk about the downsides of Wi-Fi today, the issues with it, in order to get to lower latency applications with the QoS. And so this document really does address many of these shortcomings of Wi-Fi and what we need to do to get there.
And also with AX, we thought that OFDMA was going to be it, right? Was going to be allowing us to do more real-time applications and different RU size to fit different
Yes.
packets or frame size, and so
Yeah.
and in this document they actually have a section on OFDMA for real-time application, and they talk about how we can actually enhance OFDMA we have today, in order to maybe improve it for real-time applications. Um, and they say that right now the WebDMA version we have, it says that it may need some enhancement if we want to support extremely low latency traffic.
Yeah.
And this is the first enhancement we could actually try to implement is to allocate some resource units for stations, like and then the AP should know that the station has some urgent data to be delivered to the AP. So, and they're talking about being able to identify what type of traffic the station is sending, and they're saying that's something we don't know right now in OFDMA, and it's something that we should try to incorporate into the new version, I guess, so you can know that client needs to send right now. It's real-time application. That client is just like web web traffic. You can wait. And then the AP will be able to take that information to do the RU allocations.
Right. So that goes back to QoS implementation of Wi-Fi, and then attacking the way OFDMA was implemented in AX, where you have a strict way of using resource units, and in BE they want to utilize be more flexible with resource units, be able to even support multiple RU per station, or even dedicated RUs for again that QoS capability, and also for the real-time applications. So even looking then at like downlink and uplink transmissions, even that has to do with OFDMA. There's still so much that goes into it, because I think the problem with OFDMA will be how it is actually implemented on the vendor side, because the ADA 211AX draft document doesn't specify how it should be done.
Exactly, and that's one thing to say in the document, and to say the major drawback of the multi-RU assignment is implementation and scheduling complexity. So that's also something they're talking about, like talking about the fact of maybe assigning multiple RUs to a station, right? Or assigning different sizes in RUs.
Yeah.
And they said that this sounds like a good idea, but it adds complexity in the scheduling process. And like you said, the scheduling process is not defined in the standard. So it's something the vendors have to come up with. And it's a balance of, how long does it take to do the scheduling versus how much efficiency do you gain by using OFDMA, right?
You have the efficiency that OFDMA brings, but then the inefficiency in trying to figure that
scheduling.
out. Yeah, the scheduling part. And that's where each vendor is going to be very unique. It's going to come down to whoever works at each vendor and how good they are at this implementation and putting it into the drivers and whatever algorithms they got to use to make it efficient. And I think that's where we'll see differences in different vendors now, because right now I feel like personally, I feel like it doesn't really matter which vendor you go with. If you're just talking about like average Wi-Fi for an organization, most organizations don't really have very specific requirements from an AP vendor. They just need Wi-Fi, right? They just need it to work. They're not going to use some of these super advanced features on the software side. But then when AX is really out there, you may want to look at how resource units is actually implemented with these vendors, and then test it out between vendors and see which one you get the best performance out of.
And also something you might ask yourself is, why isn't OFDMA straightforward when we've been using it in LT for years?
Yes.
And they have a sentence in the document that kind of talks about it. They said, in Wi-Fi networks, resource units form a complex structure. So the resource allocation algorithm are not such straightforward as in LTE. So I don't know exactly the details, but that gives you a hint of how it would be different. It would be difference between Wi-Fi and LTE. And then they're talking about the fact that, in Wi-Fi 7, we're going to have wider channels, which means, more resource units, which means the scheduling problems becomes more challenging because now you have more resource units to allocate, right?
Mm-hmm. Yeah.
And
and when you look at
resource.
Oh, go ahead.
No, I was going to say I was going to read the sentence that says, since the resource allocation policies are left out of the scope of the standard, these open issues require much attention from the vendors and the academic community, like you were saying.
I was actually going to read the part. It's funny because you and I both have almost the same highlights. That piece to me was a really important sentence because the IEEE does not have what they say, like a policy that tells these vendors how to implement it. So we are left to just follow how the vendors do it. And the vendors may look at these documents from the academic community, but they do implement it differently and they do interpret it differently. And so then that's where we have the issues of how OFDMA resource units are allocated. And maybe
also the vendors, they're like, obviously it's a business, right? They're revenue driven. So they allocate time and resources where it makes sense from a financial standpoint, versus academic is more like, it's not how they see money spending, I guess. They're spending more on research and R&D and stuff like that.
I think if a vendor wants to be a leader, then they should spend the time and effort on OFDMA. That is going to be like, if they can implement that efficiently and better than their competitor, then we can see the real benefits of Wi-Fi 6.
Yeah. So that was the section on OFDMA, which was pretty interesting, I think.
Yeah.
Knowing, everything we know today with Wi-Fi 6. Something they talk about is multi-link operations.
How did you interpret that, Francois, multi-link operation?
Yeah. So multi-link is pretty much the ability to send on multiple channels. You could see it that way.
Yeah, that's what I was thinking too. Like I was, the term multi-link operation was kind of confusing to me.
Yeah, because well, I guess when you read the document, they talk about, how in 11 AD, which is AD, it's the operation on 60 gigahertz. They says in ADs, they already have multi-band implemented because, if the connection doesn't work in 60 gig, they want to have a fallback on 5 gigahertz, right? Mm-hmm. So they have this kind of multi-band. It's used as a protection mechanism to make sure that, you still have a connection even though the line of sight of the millimeter 60 gigahertz wave is not there anymore. Yeah, so they talk about that, and they talk about a couple of challenges with that. And this is one of the challenges is, when you in Wi-Fi, when you transmit, on closer channels, you're going to use higher power. So if you're trying to have multi-links on the same frequency band, you could have some interference. Mm-hmm. So they're saying that it will work better if it's operating on different different frequency bands, right?
Which we can achieve with the 6 gigahertz spectrum.
Yeah, that's what they're saying. They said, it can do simultaneous transmission and reception in different bands, 2.45 and 6 gigahertz. And also they're saying that, multi-link operations could aggregate various number of links of different width. So you could have like 80 megahertz wide channels on one link, and then a 20 megahertz on another. And you could be flexible in the way you could, size those links, I guess.
Yeah.
Yeah. And then they're saying that, 11b will allow sending packets concurrently on multiple channels. And so they're saying this is the alternative to wider channels. And they're saying wider channels have problems, right? You increase the noise. You have this the issue we talked about when we talked about preamble puncturing. So they're saying instead of having like a 320 megahertz wide channels, we could have like a multi-link of 180 in one band and another on 160 on another, whatever. Yeah, and you could still improve links. the throughput, but by just making sure you're I guess using the spectrum differently, I guess.
Yeah, and then they would just be combined down at the driver level, down at the the LLC layer, and then I guess the challenge with that is battery, right? If we talk about our mobile devices, how are we going to fit another link or another radio to do this? Because most already the devices are still two spatial streams. We would have to then have better battery technology to really utilize this. Like I can see this happening, but constrained by device size and the power it consumes to do this.
Yeah, and they're also talking about something like talking about the asynchronous and synchronous multi-link. And they're talking about the fact that if you do asynchronous, so if you like sending and receiving at the same time on different links, you could have interference from what you're receiving versus what you're sending. Yeah. Because when you're sending, you're using much higher power than when you're receiving.
Yes.
So they're saying the solution might be synchronous multi-link. So you only send at the same time on the different links and receive at the same time on the different links. That's what I understood from it. But if you do that, then you're losing some of the efficiency, right? So they're saying that there's a lot of, they call them open issues, but there's a lot of questions around the feasibility of it. And they said that there needs to be a lot of testing, especially around synchronous, asynchronous. Can you do it on the same frequency band? Will it be, reserved for, multi-band operations and all of that?
Yeah, it's more of this sounds like it could work. It's more of a theory at this point because they are considering it, but it's
very interesting though,
because it would increase, not increase, but decrease latency and increase the efficiency. And you have at least two methods, but then it'll be, if it gets implemented into a draft document, I'd be curious like which one would be required and which one's optional, because that's how these features work, right? It's like the vendors who are part of this discussion probably go, I want the synchronous to be required, but not the asynchronous.
Yeah, and this is a big change because it changes a lot of things, and they talk about that. They talk about, how do you do power saving now on the multi-link gig, and how do you do real-time application and all of this, right? And because it has like a brand new architecture, and they have something called the multi-link device, right? And you have one multi-link device per transmission, and they're talking about the fact that they have different MAC addresses and all of that. So it's kind of like a whole different game. But it's very interesting to read.
Yeah, and then even if you go even further on this multi-link, there is something called duplicate mode or joint mode. So duplicate mode is similar, I guess, like to the synchronous part where it's a copy of the data sent on both links. Joint mode, you're just using both links for different data. And so there's still more options available. So they look at what they think is the better option, and then, if that doesn't work, let's look at some other options to still increase the efficiency here and get higher throughput.
Yeah, so I guess we'll see. Multi-link, we'll see how it works. Like you were saying, I wouldn't be surprised maybe if we see it for like 6 gigahertz, maybe between 6 gigahertz and 5 gigahertz. I think that would be a good use case for us in the future.
Yeah.
All right, next. So I wanted to move on to the next
we're
piece.
like 45 minutes into this.
Yeah, I know. This is crazy, huh? But the next piece I think is important because it's related to multi-user MIMO.
Yes.
And we all know that multi-user MIMO today is not really working.
What?
What? And the reason why it's not working is because of the amount of overhead generated by the sounding process.
Yeah, you and I were talking about this before we started, because MIMO is an interesting topic, and it's hard to, I find it's hard for the average person to know whether or not that's working, right? It's a feature that's there. It's key to higher throughput with multiple spatial streams, but to understand how MIMO works, or MU MIMO, like there's so much that complexity that goes into it that in the end, it's probably not even worth it.
Yeah. Well, it's today in our networks, it's usually the case. And if you want to know if multi-user MIMO is enabled on your network, you can do packet captures. You'll see it, and they so you have those frames, those what is it? I think it's called ND.
Null data packet frames.
Yeah, NDP frames, and you see NDPs, null data packets. You'll see a whole bunch of them. So, and you'll be able to see if multi-user MIMO is enabled or not. Maybe we'll do some more work on that.
Yeah, we were talking about testing things from our environments, combining what we see, and comparing some vendors to see how MU MIMO was implemented and how it affects the wireless network. Because in this case of BE, they're going to have to leverage MU MIMO, and they do talk about the shortcomings of it currently, because if we're looking at 16 spatial streams, you would have to leverage MU MIMO to get the throughput. But if you implement it as it is currently, the overhead will be enormous, right? Because of all these channel sounding frames that go back and forth, your beamforming reports, there's just so much communication to get MIMO or MU MIMO to work that is there any clear benefit because of that overhead?
Yeah, and they did some calculation, and they said that in order for multi-user MIMO to work, the AP needs to understand needs to understand how the client see different streams. But if you're using 16 streams, the AP needs to know the information about 16 of them, and they calculated that the overhead for a 16 spatial stream, transmission would be 10 milliseconds. So that would be actually, more than the transmission of the data, maybe twice as more.
Yeah, it defeats the whole low latency purpose there.
Yeah, it defeats the whole purpose. Yeah. So they say the duration of the procedure reaches 10 millisecond, channel measurement becomes useless since the channel varies significantly between the NDP and the following data transmission. So they're saying because of the RF environment changes all the time, you do the sounding process, but between the time you do the sounding process and the time you send the data, because it takes so long, maybe it's going to change, and then your sounding process is not viable anymore. So
yeah, and considering that the way it's done now, I think it's most vendors are using explicit sounding. I think that's what it is, right? And they want to bring back implicit sounding. I guess implicit sounding it's been there. It's just been an optional thing, and so they want to bring that back, because that in order to reduce that overhead, they're going to leave most of this to the AP to do the sounding process versus having to wait with the clients to check every single spatial stream and then send all those frames back and forth. And so they're trying to enhance the way the sounding process is done.
And they're also looking at an alternative technique called orthogonal sequence-based reference signal, or OSRS. But they said that the current results show that the OSRS technique has worse performance than the tone interleaving that I guess we're using today because of cross-stream leakage. And then it's like more evidence is needed to decide which method to use.
That
So
part
this
to
work
me
is in
went over my
progress.
head. Went over my head at that point. I would
Oh my God,
never
so-
know if there was cross-stream leakage or not. And that sounds weird too.
Okay, so if we go back to the open issues for channel sounding, they said they're saying that as 11B increases the number of spatial streams and bandwidth, the channel sounding shortening becomes especially crucial. Unaffordable overhead induced by the legacy sounding methods makes BE change the paradigm and develop method efficiency for massive multi-user MIMO systems.
I mean, this is not just a problem for channel sounding, but when we move to 6 gigahertz, the amount of channels available, the time it takes to go through every single channel, right? Like, let's say you have an implementation where the vendor goes, all right, let's do some sounding, and what about all the other channels, guys? Like, how are those channels for you guys? Like, there's no way a client is going to spend an efficient amount of time going through every channel. And I'm not just talking about channel sounding, but like just scanning through every single channel. And I'm curious like how that will be implemented for 6 gigahertz.
Yeah. And then I think they briefly talk about it too, but how do you make OFDMA and multi-user MIMO work at the same time with the scheduling and the different streams? That's also like another story, like that increases the complexity by a lot.
Yeah, I don't think that'll be implemented at all.
Yeah. Then why do we need 16 special streams then?
Maybe from the AP to client perspective. I don't know. It's the algorithms for this thing sounds complicated, sequence of events and the quality of the programming of the drivers. This looks really complex.
And we've been talking only about the Mac enhancements. They also talk about some of the PHY enhancements, and they talk about 3 of them. The first one is something called HARC, which stands for Hybrid Automatic Retransmission Control, and it's just a way that they're trying to see how they could improve the retry process. Then the second enhancement is called Full Duplex.
Oh yeah,
I think this one everyone knows about full duplex, and so they're talking about the fact that they've been studying full duplex over Wi-Fi connection for a long time, but it's
group.
Not. Yeah, 2018, I think they say.
Yeah, wow. What's going on with
it? and they say by now none of the full duplex solution receives sufficient support within the task group, the 11B task group, because of unclear gain in real deployments, right? And
is it possible to use LTE as an example?
They say how to modify the transmission protocol, which stations can be involved in full duplex, how to combine full duplex and multi OFDMA, how to keep backward compatibility, etc. is a challenge. So
the whole backward compatibility comes to stab us in the back again.
And the third PHY enhancement they talk about is the non-orthogonal multiple access, so the NOMA. And the basic idea of NOMA is that an AP can serve multiple stations simultaneously in the same baseband by allocating portion of the total transmission power for each station. So send that different power, which sounds mind-blowing to me. I need to do more reading on that.
Yeah, the next following sections are all very complex and beyond what I know about Wi-Fi. There's the theory in this is high.
Yeah, and then they have a section on multi-AP cooperation.
Yeah, that part I'm really interested in.
Yeah, this part is interesting. Yeah. So
what's funny is they mention very specific vendors in this section too. Yeah, the state of the art enterprise Wi-Fi networks often use cloud-based solutions such as Cisco Meraki, Quantenna, Maui, and Huawei Agile. And so they're talking about the seamless roaming between Wi-Fi networks. 'Cause, that's important, right? For today's networks, and discussing about how you can improve how APs coordinate with each other, to just improve how we use like the spatial reuse, and having to lessen the effects of OBSS.
Yeah, and also ease the transition.
Yeah, so the coordination is key, but again, like that's something that's kind of attached to the device and how the device will roam. But then here, I think they're talking about it being more deterministic, right? Maybe the AP takes control of that process, but then I see the shift going that way. But how are the devices going to play with it? Yeah, are the device manufacturers going to implement these things the same way and be able to say, all right, I will listen to how the AP wants to do the communication, and I'll listen to it, versus the device manufacturers having their secret sauce as far as how they interact with the Wi-Fi network.
Yeah. So that's when I guess we'll have to do some more testing and all.
I don't even think we can test it.
Well, I mean, when they start doing some actual practical tests
next year,
rather than I don't know. I don't know if it's going to be next year.
The draft will be next year, right?
So this will be like the multi-AP corporation. I don't think it's part of release 1.
Yeah, this part seems very complex above everything else, because we're talking about coordination between APs and more sounding protocols, null steering. Like, all of this sounds nice in theory. Not sure how this will work in today's networks.
And they have the author of the document, they summarize the different improvement, the innovations for 11B in a nice table, and they tell you, which one is going to improve the throughput, which one will improve the spectrum efficiency, and which one will be good for real-time applications. So we'll put that table in the show notes so you guys can take a look at it.
Yeah.
We talked a lot of about a lot of things here, but we're reaching the hour mark, so.
I think we pretty much went through the whole thing.
Yeah.
Made it.
I would recommend you guys take a look at the document if you
guys have the
can
time.
Focus for a couple of hours.
You really have to focus when you read this document, because it is complex. It makes you start thinking about the future and where these guys, these really smart guys, start seeing the shortcomings of how Wi-Fi works today. Because in practice, like, how is this going to work, right? In practice, we don't really see the claims that we see in the technical documents, and these more formal documents. The real world's just, I don't know if it'll be different with BE, right? What do you think, Francois? Should we skip 11AX 6 gigahertz and wait for 11BE? That's the real question, right?
I think it's for us engineers and working in the field with the technology and seeing how it's operating, seeing exactly what type of throughput we can get out of the client devices today. I think it's when we read this document, it would be a good critical thinking exercise to try to see, okay, out of all of this, what do I think will be viable in the real world, right? Which improvement or enhancement can actually make sense in the real world, right?
I would say when you do see this document, look at the references and all the documents that they reference to put this single document together. And you will probably learn a lot more from reading these documents than, say, reading a textbook, because a lot of these guys, like what I've been starting to do is look at the authors and see, you know, how has this author participated in the development of these protocols, and how often are they publishing documents. And so you could see how they had envisioned Wi-Fi to be and compare that to how we see it today. And then maybe you'll be able to come to your own conclusions with some of these implementations and going, all right, you know, maybe MU MIMO is not working as efficiently because here's what I can see. And I'm using that as an example because you and I, Francois, are probably going to do something to look at it in depth. And then you could maybe have that option to just disable it and compare how your Wi-Fi network is operating without some of these features enabled.
And have 185 references. Just so you know.
Yeah, because initially I was looking at the document like, this is a lot of pages, and then when you look at if you go all the way to the end, it's like 3 of those pages are just references, 3 or 4 pages.
Yeah, and it's mainly like research paper, and then in there you see a Meraki datasheet. So I was like, what?
Yeah, I was very curious, like why they mention specific vendors. Like, but I have my own thoughts about Meraki.
It was just funny to me how they put a data sheet in the middle of a whole bunch of research paper.
Yeah, I mean, one of the first few references are Matthew Gass, his survival
guides. Yeah,
and I would recommend you guys pick those up. Even the older protocols like 11N, 11AC, like those books are really good.
Yeah. It's kind of like the readable standard.
Yeah, exactly. He breaks it down much easier. So in the end, like, this is just forward thinking, right? None of this is going to, some of this may not even make it to the draft version or even to the final version of 11BE, but it's fun to think about what's coming up next for Wi-Fi, how we should think about the upcoming mainstream 11AX and 6 gigahertz, and where we should start thinking about future deployments, because obviously they are focusing on low latency applications, high throughput, 8K, because by the time this 11BE gets released, we will probably be at 8K, right? 4K is now coming out, although I don't know how many people are doing 4K over wireless, maybe through like augmented reality or virtual reality. I've seen very small use cases in that regards, but I know the use cases that I have seen, they're using a wired connection versus a wireless. So it's interesting. Like, if you've been to the Microsoft store, I don't know, Francois, if you've been to a Microsoft store and you've seen them with those VR goggles. Have you seen that before?
No, I haven't seen that.
Okay, so this is where I've seen wireless implemented. There's a lot of data that gets thrown over wireless with this technology using the VR. They had a computer and you wear the goggles and there's all this other stuff. But I had asked one of the people like how it's being used, and they were using, or I know I looked at a data sheet and it was using 60 gigahertz to do the communication. Okay. So like it's there. It's just not a lot of people are using it, right? Because one, it's still expensive to even get that solution. But as prices go down, then we'll start seeing more of these, more use cases, the innovation around it, and that's why we get to this point where Wi-Fi looks very complicated at 11BE because it's trying to address a lot of those issues that are going to come up.
As you were talking, I was shopping for my 8K TV. You can buy 8K TV 82 inches for $7,000.
Oh, that's it?
It's there. You just have an AC card in it.
Limited by the card.
Oh,
All right, guys.
anyway.
If you want to see the document, head over to the show notes and we'll link out to it there. Let us know what you think in the comment section about 11BE. If it seems interesting to you, if you think it's a no-go, dead on arrival kind of thing, let us know.
Well, thank you guys for listening. And I guess we'll see you next week with a brand new episode.
All right. Bye, guys.
Bye, guys. Bye-bye.